This is Organic ISP video 2. Right? We're starting off with nomenclature. Right? The organic nomenclature system is required because of the variety of organic compounds that I mentioned. When we start with the backbone of organic nomenclature, both literally and figuratively, right? We start with straight chain alkanes. Right? And alkanes are hydrocarbons, so they only contain carbon and hydrogen. And alkanes have the general formula CN H2N plus 2. Right? We can't call them all carbon hydrides. Right? So we need to come up with a more extensive naming system so that we can cover the variety. The system we're going to start with is prefixes in order to tell you how many carbons are in the chain. Right? We're only going to be dealing with chains up to a length of 10. Right? So here are the first 10 prefixes. Right? 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, which I don't want you to mistake for sept. Right? Often people I see sept put in for 7 because I guess of Latin-based languages like French, the number 7 is sept. Right? The 7 prefix is actually hept with an H, oct for 8, non for 9, and dec for 10. Right? All we have to do then is for straight chain alkanes, we're going to put in the prefix ane, the suffix ane, right, at the end of every prefix in order to name the alkane with that chain length. So we all know methane, right? That's just CH4. It's the simplest alkane molecule, right? And one of the simplest organic molecules in general. Ethane, right, is then just 2 carbons, and it'll have 6 hydrogens on it. Then we have propane. We know propane from barbecues, right? We can start drawing skeletal structures now. Right? Just looks like that. It has 1, 2, 3 carbons. Butane might also be familiar. Butane is used in barbecue lighters. Right? It has 1, 2, 3, 4. Pentane, 1, 2, 3, 4, 5. Hexane, 1, 2, 3, 4, 5, 6. Heptane, 1, 2, 3, 4, 5, 6, 7. Octane, 1, 2, 3, 4, 5, 6, 7, 8. Octane's probably a familiar one as well because it's the major component of gasoline. All right, nonane, 1, 2, 3, 4, 5, 6, 7, 8, 9. And decane, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? The only thing that I should point out at this point is that these are drawn in straight zigzags, but as I mentioned in the previous video, sometimes you may see these chains in a configuration which is not straight. For example, if I took hexane, right, I could draw 1, 2, 3, 4, 5, 6 like that, right? And that's still hexane. It still has 1, 2, 3, 4, 5, 6 carbons. I've just changed the direction of the chain, right? If I were to do this, 1, 2, 3, 4, 5, 6, 7, right? That would be 1, 2, 3, 4, 5, sorry, that's a 6, 7, right? That would be a heptane, even though again, it's not in a straight configuration, right? And that's just so that you realize we don't have to follow chains in straight lines. We can follow them in any direction we want, and that becomes important in the next part of naming, right? So for now, really all you need to know for straight chain alkanes is these 10 alkane molecules, right? They start with a prefix to tell you how many carbons are in the chain, and they all end with the suffix ane to tell you that they're alkanes.